Okay, hi. Today we are going to look at the CHIJ St. Nicholas Girls Primary School 2021. So we will spend about 1 hour to go through this paper, and so look out for shortcuts, right? Shortcuts and methods. So the purpose, how to do well for paper 1 is to know your shortcuts and also to know the methods to solve harder problems. So let's start with question 1, and okay, now, okay, so question 1. Okay, so 5 10,000s, 7,000s plus 18 tens is equal to what number? Now for this question, you will need to change every word into a numeral. So 5 10,000s is 50, right? 5 10 means 5 times 10,000. So 5 times 10,000, that will be 50,000. And then you have 7,000s, which is you just have to add 3 zeros behind, and 18 tens, just add 1 zero behind. Okay, so once you have all the numerals already, then what you do is don't do mental sums. You should try to do working. Of course, if there are some numbers if you can do some mental sum for some small numbers, then you go ahead. But otherwise, if the numbers are very big, then you should do the working on the paper so that you don't make any careless mistakes. So the numeral, the numeral will be 57,180. So your answer should be number 4. Okay, so let's go to next one. What is the sum of the factors of 15? You must first know what are factors, how to find factors of 15. So you take 1 times 15 is equal to 15. And then 2 is not a factor because 15 cannot divide by 2. Then the next one will be 3 times 5 equal 15. And then 4 cannot because 15 cannot divide by 4. 5 times 3 have already. All right, so these are the factors of 15, and then you will need to find the sum. So you have to add them all together. So you have 1 plus 3 plus 5 plus 15. Okay, how to do faster without making a mistake over here? You can actually do pairing. Okay, pair the numbers together, and you will find that it's easier to add the numbers together. So that will be 24. All right, so answer will be number 4. Okay, the next one, question number 3. Mr. Chan wanted to buy 4 shirts at $M each. So he was short of $12. It means that he doesn't have enough money to buy. So how much money did Mr. Chan have? So you will need to find how much is the 4 shirts. So 1 shirt is $M. So you have 4 times M. That will give you $4M. So he will need $4M to buy the shirt. But he doesn't have this money. He was short of. Short of means you don't have enough money. You don't have $12. So you will have to take 4M and minus $12. All right. And that will give you the money that he has actually. So how much does he have? So 4M minus 12. So answer will be number 2. So when you see the word short of, it means that you don't have enough money. So we have to minus. Okay, minus when you don't have enough. Okay, so let's go to the next one. Question number 4. And the table shows the number of cookies sold by Awesome Bakery on Monday. So to do this question, if it's a bar graph or line graph, you will need to put the numbers on the bar graph or on the line graph. So you have to count the gaps, right? Count the gaps. And how do you count the gaps? 1, 2, 3, 4, 5. So there are 5 gaps. And how many is 5 gaps? 10 minus 0 will be 10. So your 1 gap will be 10 divided by 5, which is 2. Then you can put the numbers on the bar graph. So chocolate will be 32, 34, 36, 36. And then your butter cookies will be 20. And then your peanut cookies will be 24. All right, so this is the first thing that you must do first before you can solve the problem. So 1 cookie costs $2. So how much money did Awesome Bakery collect on Monday? So if you look at Monday means all the cookies sold on Monday, right? So you have to add them all together. So 36 plus 24, right, do your working, that'll be 60. 60 plus 20, that will be 80. So he sold 80 cookies altogether, and then you multiply by $2 each. So he will collect $160. So answer number 1. Okay, let's go to number 5. And what do we have? Shifting of decimal point. So when 34.076 is multiplied by 100, so you will have to shift the decimal point to the right 2 times because there are 2 zeros. So when you times or multiply, you have to shift the decimal point to the right, 1 and 2. So your answer will be 3407.6. And what does the digit 7 stands for? Now, the number in front of the decimal point, which is over here, that is your whole number. Okay, whole number. So the digit 7 will be ones. Okay, ones. So you have 7 ones, and then this will be tens, hundreds, and thousands. And the digit behind the decimal point will be the tenth. Okay, the tens. All right, behind the decimal point. So what does the digit 7 stands for? 7 ones. So answer number 1. Okay, let's go to the next one, question number 6. And okay, William made honey drink for a party. He mixed honey and lemon juice in the ratio 1:4. And he used 600 ml of honey. So how much lemon juice did he use? All right, this is a ratio problem. So we are going to use the ratio method. Okay, ratio method means what? It means that you have to label the ratio first. So you have honey is to lemon juice. Honey is to lemon juice, right? To make honey drink, okay? To make honey drink, right? So you can put a total there, right? A total if you want. That is a total, that's a mixture. And the ratio of honey to lemon juice is 1:4. And the total is 5 units. And he used 600 ml. Okay, 600 ml of lemon, which is 1 unit. So how much lemon juice did he use? That will be 4 units. So you take 600 times 4, all right? And of course, there's a shortcut. The shortcut is to cover the zeros. Yeah, 6 times 4, 24. And you put back the 2 zeros. And that will be 2,400 ml. So how much lemon juice did he use? He must have used 2,400 ml of lemon juice. So not really, okay, what is ratio method? Ratio method means you have to what? Ratio method means you use ratio, okay, ratio to actually solve the problem. So when you use ratio, you have to label the ratio. So once you label the ratio like this, you are actually using ratio method, okay, ratio method. Okay, now which one of the following shapes has only one line of symmetry? So you look at number 1. So number 1, you can see that you actually cut the oval into half. So there's a line of symmetry. That's one line. For number 2, there is no line of symmetry. Okay, for number 3, also there is no line of symmetry. All right, because number 3, it doesn't look symmetrical. So how do you know whether they look symmetrical? You have to fold the paper, fold the diagram into half, right? And then you see whether does one side of the diagram fit nicely with the other side when you fold. So when you fold the diagram into half, right, into half, both sides must fit nicely onto each other. Otherwise, if you see something like this, right, if you fold and something comes out, then that is not symmetrical, right? So for number 1, that is symmetrical. It has only one line of symmetry. For number 2 and number 3, they are not symmetrical. And for number 4, you also have a line of symmetry. And you can see that number 1 and number 4 seems to be the answer, right? But the question says, which diagram has only one line of symmetry? If you look at the oval, you can have another line of symmetry. So figure 1 or option 1 has 2 lines of symmetry. So number 1 is wrong because you only want one line. Okay, only one line. So your answer has to be number 4. Okay, all right, so let's go to the next one. And okay, now this question is quite popular, and most students will have a tendency to get it wrong. So how do you get your percentage? How do you change decimal to percentage? You always remember that fraction, right? Fraction is percentage best friend. So to get your percentage, you always try to get fraction. So can you change the decimal into a fraction, which is 1 and 7/10? All right, that's a mixed fraction. And then change the denominator, change the mixed number into an improper fraction. So 1 times 10 and then plus 7. And you will get 17/10. And how do you get your percentage? You have to make sure the denominator is 100. So can we change the denominator into 100? 10 times 10 and 17 times 10. And once your denominator is 100, then how many percent? That will be 170%. So your answer will be number 4. Okay, so fraction is the best friend of percentage. So every time you see percentage and you don't know how to do, think about fractions. Think about getting fractions to get your percentage later. Okay, question 9, volume. A rectangular tank with a square base of side 8 cm and the height of 10 cm is 3/8 filled with water. So what's the water in the tank? So there is a simple method here, or not really a method, but to help you to know how to do this problem is to put the fractions into the diagram. So the water is 3/8, the water is 3/8, and the empty space is 5 units or 5/8, and the whole container is 1 whole. So draw a diagram. All right, that's a method, but the diagram is drawn for you already. So what you do is you add the information, add the fractions, put numbers into your pictures like this, so that it helps you to know what to do next. So if the whole container is 1 whole, then 8/8 is 8 unit. And what is the volume of the whole container? So 8 cm times 8 cm times 10. So 8 times 8 is 64. 64 times 10 is 640. So what is 1 unit? So 1 unit will be 640, and then you divide by 8. So you cover the 0. 64 divided by 8, that will give you 8, and put back the 0. So 1/8 or 1 unit is 80 ml. And how many units of water inside the container, which is 3/8. So you take 3 units times 80, or 3 times 80. So that will give you 240 ml of water in the container, right? So answer number 1. Okay, so how to do this? You put the fractions into the problem, into the picture, and then you can see more clearly and you will know what to do next. Okay, question number 10, timeline. So how long is the clinic open on a Wednesday? So from 8:30 to 12:30 p.m., that will be 4 hours. How do you get that? Do finger counting, right? Use your fingers to count. So you have 9:30, 10, 11:30, and 12:30, 4 hours. And then 2 to 5 p.m. will be 3 o'clock, that's 1 hour later, 4 and 5. So you have 3 hours. And then 7:30 to 9 p.m., well, you can do some mental. 7:30 to 8:30 is 1 hour. All right, 1 hour. Then 8:30 to 9 p.m. will be 30 minutes. Now, if you are unable to do mentally, then you draw a timeline. Okay, a timeline. Okay, so you are looking at how long is the clinic open on a weekday, on a Wednesday. So you should be looking at here and not this one, okay? Because these are weekends. So what is the total time that the clinic is open? So you have 4 plus 3 plus 1, that will be 8 hours and 30 minutes. Okay, so your answer will be number 3. All right, so the first 10 questions are usually generally very easy. So you should try to score well for the first 10 questions in your paper 1, all right, in your PSLE. Okay, let's look at question 11, gets more steps, a little harder. Now, this is an age problem. So every time there's an age problem, then it is always usually a before and after problem. So you may want to draw before and after model. So Mrs. Ong is 36 years older than Pauline, which is what? Which is before, okay, before. So, or you can call it the now, how old they are now. So you draw a model, Mrs. Ong and Pauline, okay, Pauline. So Mrs. Ong is older, something like that. And she's 36 years older. And what is after? After means 5 years later, all right, after. So you have Mrs. Ong again. All right, so what's the method here? The method here is to draw model. So 5 years time, what will happen to their model? Their model will become longer in 5 years time. So you should be drawing something a bit longer. No space. Okay, there's no space. Okay, maybe I should draw. Okay, let me just erase everything and draw a bit smaller because there's no space. And so in the exam, if you find that there's no space to draw your model, then it's okay to just adjust it and make sure that your model is well drawn. Okay, and if it's untidy or too small, you won't be able to analyze your model. Okay, so let's try again. So before model and after model. Okay, and then Mrs. Ong and then Pauline. And Mrs. Ong will be something like that. Okay, something like that. And Mrs. Ong is 36 years older. All right, older than Pauline. And in 5 years' time, what will happen? Okay. Oh, this year. Okay, this year. this year Mrs. Ong is 4 times of Pauline's age. And how old is Pauline? How old is Pauline in 5 years' time? Okay, so we need to cut the rectangle for Mrs. Ong 4 years' time. Okay, 4 years' time, like this. Yeah, I think I read a little bit too fast. Okay, so let's adjust it and something like this. Okay, something like this. Okay, so Mrs. Ong is 36 years older than Pauline, and this year Mrs. Ong is 4 times of Pauline's age. How old is Pauline in 5 years' time? So in 5 years' time, they should become older. So you must draw a bit longer, and that'll be 5 years' time, right? 5 years later. All right. So what is the unchanged? So this is a before and after problem. What is unchanged? If it's an age problem, the age difference is unchanged. Okay, which is still 36. Okay, and your question mark, how old is Pauline in 5 years' time? And that's it. Okay, that's your model. All right, then you can start looking at the model to solve already. So you have 4 units and here 1 unit. So your 3 units is 36. All right, you can start writing. 3 unit is 36. Then your 1 unit will be 12. And then what's the total age, which is 5 units. So 36 or 12 times 5 is 60. 60. So you will get total age is 60. All right, that is their total age now. So in 5 years' time, what is their total age? Can you find their total age in 5 years' time? So you must take 60 plus 5 years later for Mrs. Ong, and also plus another 5 years later for Pauline. That will give you 70. So their total age in 5 years' time will be 70. Then you take 70 and you minus 36 and then divide by 2. Okay, so you take 70 minus 36 and you will get 34. And then 34, and then you divide by 2 because there are 2 boxes below, right? 2 boxes that look the same over here. And you divide by 2, you will get 17. So this is 17, okay? 17, and here also 17. So how old is Pauline in 5 years' time? So your answer will be 17 years. Okay, so question 11, the answer is 4. So what's the method? What's the method over here? If it's an age problem, right, usually it's a before and after problem. Then you can draw your model. And what is unchanged in this problem? The age difference. The age difference is always the same. Okay, let's go to number 12. And okay, you have a line graph. So Mrs. Tan bought 4 types of fruits. Okay, 4 types of fruit. The apples was 2/3 the number of oranges. So this is 2 units, and the oranges will be 3 units. The ratio of the pears to the oranges was 2:1. Mrs. Tan bought the least number of watermelons. So which one of the following graph represent the information above? Okay, now there's a fraction, there's a ratio. So what do? Okay, now you will have to compare them, right? To find which has the most, which kind of fruits has the most, and which kind of fruits has the least. So how do you compare them? By using ratio to compare, right? Ratio. So you will use ratio method and to find out which fruit has the least and the most. So you have apples is to oranges, 2:3, and then you have pears to oranges. All right, pears to oranges. Okay, apples to oranges. Okay, let me see the apples to the oranges. Okay, let me just write again. Okay, let me just write nicely. So apples to oranges. Okay, apples to oranges. You have 2:3, and then you have the pears to oranges, which is 2:1. So what do you see? You can see that oranges, the same. So you will have to make the number equal. So times 2, and then you will get 4:2. Oh no, times 3. Okay, times 3. okay, hang on for a while. Let me just times. Why did I times 2 times? Okay, all right, times 3. Okay, times 3. Okay, let me just try again. You have to times 3, right, to make the oranges equal, and then this one times 3. And then what do you get? You will get 6:3, and this will be still 2:3. So once you make them equal, then you can call them units. Okay, call them units. All right. Okay. All right. Okay, let me just adjust a little bit, make it look a bit neat. So this will be 6 unit is to 3 units. Okay. And then Mr. Stan bought the least watermelons. All right. So if you look carefully, which one is the most? Apples is 2, oranges is 3, pears is 6. So you have pears, which is the highest, right? The highest. So if you look at number 1 and number 2, all right, number 1 and number 2, you can see that the pears, right? The pears is the highest point because you have the most number of units, right? So number 3 is wrong because you can see that oranges is the most. Number 4 is also wrong, all right, because it's not, oranges is the most, right? So that is not correct. Okay, then let's look at number 1 and number 2. Watermelon is the least. But if you look at these dots, watermelon and these apples, you can see that they are equal. But we don't have equal number of watermelons and apples. The question says that the watermelon is the least, okay, the least. So it must have the lowest point, okay, the lowest point. And if you compare the apples and the oranges, you can see that the oranges is how many units? The oranges is 3 units and the apples is 2 units. So there are more oranges than apple. So you can see over here, there are more oranges than apples, right? So which is the correct graph? So the correct graph has to be number 2, and that is the correct representation. All right. Okay, so let's go to the next one. All right, so what question is this? Question number 12, the answer is number 2. Okay, let's go to question 13. Okay, question 13, and what do we have? Fractions. So there are twice as many adults as children, and 7/9 of the children are girls. And what is the ratio of the girls to the boys? And you can see the answers are in ratio. So what method can I use? I can use ratio method. So adults is to children twice as many. Okay, and 7/9 of the children are girls. So if girls are 7 units, then the boys must be 2 units and the children must be 9 units. And then you can see that children, they are the same. So you will have to make the number equal. So you times 9. And you will get 18 is to 9, 7 is to 2 is to 9 also. All right, so once you make them equal already, you can call them units, right? All these will be units. So what is the ratio of girls to boys to adults? So you have 7 is to 2 is to 18. So answer number 4, right? So question 13, answer 4. Okay, question 14 seems to be a bit wordy. So at first, Xavier and Yaling were each facing a different direction. Xavier was facing west at first. Okay, so let's draw a compass for him. Let's draw a 8-point compass for Xavier. Okay, Xavier, right? And this is north. This is south, west, and east, and he's facing west, right? At first, and of course you have the 8-point compass, right? So he make a three-quarter turn in the clockwise direction, right? So okay, so what happened? So Xavier is facing west at first, and he make a 3/4 turn. 1/4, that's a 2/4. And 3/4 in the clockwise direction, right? And then he's now facing south, all right, the south. Okay, and then Yaling turn 135 degrees anti-clockwise, and both of them also face the same direction. So what direction was Yaling facing at first? So if both of them were facing the same direction in the end, then Yaling must also be what? Must also be facing south in the end, right? Facing south in the end. Okay, so let's draw the 8-point compass for Yaling. Okay, Yaling. And then you work backwards because you want to find what direction was she facing at first. Then you have to work backwards. So how to work backwards? the 135 degrees, you have to break up. Okay, break up into what? Break up into smaller numbers, 90 and 45. And when you work backwards, what happened? The anti-clockwise will become clockwise. So you turn clockwise 90 plus another 45. Okay, 45. So what direction was Yaling facing at first? And that must be the northwest. Okay, northwest. So Yaling must be facing northwest at first. So answer number 2. Okay, question 14, answer number 2. All right, so how to do this? You can't do mentally. You have to draw out the compass for both person, and then you have to draw. Okay, show the arrow pointing from where to find the answer. All right, so there's no mental over here. Otherwise, you most likely will make a careless mistake if you do mental. Okay, question 15. Okay, what is this? Okay, figure ACDE is made of 2 identical rectangles and three identical squares. Okay, so I think I need to, okay, I'm a little bit confused. I'm a bit confused by this diagram. 2 identical rectangles. So where are the rectangles? 2 identical rectangles and 3 identical squares. So where are the squares? Okay, okay. So where are the squares? Okay, all right. Never mind, let's read on. Now the length of AE is 3 times the length of AB. So where's AE? AE is 3 times, so that will be, yeah, 3 units. And AB will be 1 unit. So what fraction of ACDE, where's ACDE, which is the whole figure, right, is shaded. Okay, shaded. Okay, shaded. All right, so I think the shaded part is, all this, right? I'm not quite sure, but I think the shaded part is all this part that is shaded. Okay, all right, so how to find what fraction of the figure is shaded? So you can actually cut it into what? Cut it into squares. And if you cut it into squares, what will happen? There will be 9 squares. Okay, you can see there will be 9 squares in total. All right, how do you know that? Like that. Okay, you can see that what I'm doing, you cut it into 9 squares. All right, so you will have 9 squares in total. Okay, and so what fraction is shaded? Well, it's very hard to look at the shaded. So how about looking at the unshaded? If you look at the unshaded, how many squares make up the unshaded? If you look at the unshaded squares and triangles, like for example, if you look carefully, this is how many squares unshaded. So that will be 1 square unshaded. How do you know that? Because you just have to form a rectangle, which is made of 2 squares, and then divide by 2. So the triangle that you see just now is 1 square unshaded. Okay, 1 square. And over here, that will be another square unshaded, so plus 1. Okay, and then over here, okay, over here, how many squares unshaded make up this triangle, which is also 1 square? How do you know it's 1 square? Because you just have to what? You just have to form a rectangle. Okay, form a rectangle which is made of 2 squares and cut into half. So you will have 1 square unshaded for what? For the blue triangle that you see below. So there's another 1 square unshaded. And then there is half a square here, and there's a half a square. Join them together, become another 1 square. And then how about this very big triangle? How many squares make up this unshaded triangle? So same thing, you can actually draw a rectangle. Okay, draw a rectangle like this. And how many squares make up this rectangle, which is 3 squares? And then you divide by 2. All right, divide by 2 and you will get 1.5. Okay, 1.5 or 1.5 square. So 1.5 square make up this triangle, 1.5 square. So that'll be 1.5. Okay, and add them all together. So you have 1, 2, 3, 4, 4 plus 1.5. That will be 5.5. Okay, so what fraction of the figure is shaded? And you get something like that. Oh, you need to find the shaded, right? So what do you have to do? Then you must take all the squares, which is 9, and you minus how many unshaded squares? You minus 5.5, and that will give you 3.5 squares shaded, right? 3.5 squares shaded. And so you have something like this, 3.5 over 9, which looks a bit weird. All right, that's a funny fraction, right? So how to get rid of the decimal point? You just have to times 2 to get rid of the decimal point. So 3.5 times 2, that will give you 7.0, or 7 out of 18. So what fraction of the figure is shaded, which is 7 over 18? So answer number 3, right? 7 out of 18 of the figure is shaded. Okay, now this diagram is a little not clear, but can still solve. Just that you have to try to see where, try to break out the whole figure into squares, and then count how many squares are there altogether, and then find how many squares make up the unshaded. Why not the shaded? Why not the shaded? Because if you look at the shaded, you find that the shaded is a bit hard to find how many squares shaded. For example, if you look at all the triangles, if I break up the shaded figure into triangles and squares, you don't have right angles. You don't have right angles triangles, right? Okay.